questions regarding linear polarization? Or we should move to side? Okay, let's move to side. Let us consider discrete property. Circular polarization takes place when both the conditions are satisfied. It should have both I and it should have two perpendicular components. One is of same equivalent. E should have two perpendicular components of equal magnitude. So if this is E1, if this was E1 and this was E2, then it would not have been circular polarization. The magnitude of both the perpendicular components of the electric field must be same, right? It should have two perpendicular components, number one. Number two is their magnitudes must be same. Second, the phase difference between the components must be an odd multiple of 5/2. Why not an even multiple? Why not an even multiple? Can anyone tell me? Why odd? Why not even? What happens if it would have been an even multiple? If it had been an even multiple, then why it would not have been a circular polarization? Any idea? Can you just check the conditions for linear polarization? What were the conditions? What were the conditions? What were the conditions of a linear polarization? Can anybody tell me the conditions of linear polarization we discussed in the beginning of this class?
The electric field should have only one component,
Okay. If it has two
or
components, then or
if it has two components, then the perpendicular then there will be phase shift of n pi when n equal to
n is an integer. So if this phase is an even multiple, then what we need to be?
circular polarization becomes linear polarization.
Exactly. If it is become an is an even multiple, then it becomes linear. That is why we cannot take it. Is it okay? We have to take odd multiples because if we take even multiples, then it's a linear. Okay? That is why it is odd. That is why we have to take odd multiples. Okay? So let us see this a bit more. What will be EZ T? Real part of Z. Sorry. Now, who was there? Please turn off your.
আমি ওই ঘরে ছিলাম তো তোর মা ফোন করেছিল ওই জন্য তোর মা কেমন আছে তুই কেমন আছিস হ্যাঁ আমি ভালো হয়ে গেছি একটু ভালো আছি
Who is speaking? Please.
ওর মা আছে কিনা জিজ্ঞেস করো মায়ের
ওর
সাথে
মাকে জিজ্ঞেস করো আমি এখানে কাজ করছি বাইরে আছে বল তোমার ফোনে আমার ফোনে করবি শুনতে পারো
Okay. Thank you.
কেটে দাও দাও ছেলেকে দিতে আচ্ছা হ্যাঁ চুরি হচ্ছে চুরি হচ্ছে এই কারে দেন লাগে
মিলে দেবো
হ্যালো
Please mute.
দেখো দাদা
আর ছেড়ে ছেড়ে ছেড়ে
না আগে ও নিয়ে নাও তারপর ওইটা মুছতে দিয়ে এটা মুছতে দিয়েছি এটা অত মুছতে হবে না একটা ভিজে আছে
So very disturbing. Please mute. Very disturbing. Okay. So this will be clearly this will be E naught cos of omega t minus beta z. What will this be? E naught cos of omega t minus beta z minus pi by j. Okay. Is it okay? Now what is cos of theta minus pi by 2? That is cos theta cos pi by 2 plus sin theta sin pi by 2. Cos pi by 2 is 0. That is sin pi by 2 is 1 sin theta. So this becomes E naught we can take as cos of omega t minus beta z I plus sin of omega t minus beta z g, and that's it. Is it okay? Is it okay? Is it okay? Any questions?
Okay, sir.
So let us do the same analysis once again. This is my line. Please mute. Where is the CR? CR, whose voice is this? Simran and Ayush? So E of 0, 0 will be what? How much? What will be E of 0, 0? Same logic, right? Omega is equal to 2 pi f. That is 2 pi by T naught. Same thing.
E naught I के
Right. So E naught I. So this will be here. What will be this? What will be this?
Sir, E naught by root 2 I k plus E naught by root 2 j k.
Very good, very good. Somewhere here it will be. What is the distance between the origin and this point?
Sir, root over E naught by root 2 square plus E naught
This
by
point,
root
this
2
point,
square.
this point. What is the distance from the origin to this point? This point. E naught 0 0. Right? This is origin from this origin and E not E of 0 0. It will be how much? What is the distance from this point and this point? This is a point 1. So origin and point 1. What is the distance from origin?
Sir, E naught.
E naught.
E naught.
And origin and point 2?
Sir, E naught by root 2.
Sure.
Sir, E naught.
E naught again. Yes. What will be now?
So E naught j.
E naught. Very good. Right? Once again, the distance from the origin point 3 would be E naught. Now, think.
Sir, minus E naught I minus E naught j by root
Very
2.
good. Very good. So, this is somewhere here, right? And as we go on, this will fill this here, then here, then here. Okay, you can guess this. And this will create a circle. So if we add all these points, they will form a circle because all the points they are at the same distance from the origin, right? Do you agree?
Yes, sir.
Right? So this is an example of circular polarization with the first point because the electric field vector is subtends a circle. First point, is it okay? Is it okay?
Yes, sir.
Second thing, the circle is subtended in a clockwise direction or anti-clockwise direction?
Clockwise.
Clockwise. So this is an example of a right-handed circular polarization. Circular polarization is divided into two types. Circular polarization is divided into two types. First is left-handed circular polarization where the circle is supporting in anti-clockwise direction, and the other one is polarization. Okay. For left-handed, that would be minus pi by 2, that would be pi by 2. Okay. Any questions? If you are interested at home, you just take here plus pi by 2, okay, and you verify whether the circle is now supporting the anti-clockwise. Is it okay?
So can you please repeat?
Since the circle is subtended in the clockwise manner, this is an example of a right-hand circularly polarized case. Okay. Had it been subtended in anti-clockwise manner, it would have been a left-handed circularly polarized. And if you are interested, you can put here plus pi by 2 and check whether this is subtended, whether it forms a LHCP wave or not. Is it okay? Had this been plus j pi by 2, it would have been a left-handed circularly polarized. Okay. Because clearly then this would have been minus. So point 1 would have been same, point 2 would be here, point 3 would have been here, so it would have been moved in an anti-clockwise. Right? So this is circular polarization. And when we discuss antennas, we will see that some antennas give circularly polarized fields. And they are very interesting. Any questions regarding circular polarization? So questions which we can expect. For example, if I give a wave, you have to add and tell me what type of polarization is used for polarization, polarized wave. Is it linear, right circular, left circular, or elliptical? Okay. Second thing is that I give a circular polarized wave. That's a good question. Yes, we have not discussed. For this wave, we have seen that right. What is this? Assuming that the wave is propagating, what will be h?
Sir, the expression of E by eta naught.
E naught by eta naught. Okay, accepted. Then
Then we will alternate the ing.
careful. Don't just alternate.
The cos omega t minus
This
beta
will be
z
I, but this will be
j
minus j.
minus.
Sorry, this will be j and this will be minus because the wave is propagating in the k direction. I cross j is k and j cross minus I is k. I cross j is not the same as j cross. Okay, so be careful about that. Just not just simply interchange. Think about that.
In the right-handed circular polarization, as we have discussed, the last point is 0.5 t by 4 or 0.5 t by 8.
Ah, yes, sorry, 5t by 8. 5t by 4 will be here. Or wait, 5t by 4. 5t by 4 will be twice of that. So 5t by 4 it will be So if I play for if I play. Finally, elliptical polarization, it is as very simple. If the wave is not circularly polarized and not linearly polarized, then the wave must be elliptical. So if it is not circularly polarized and it is not linearly polarized, it has to be elliptical. Nothing else. Understand? Every wave is one out of the three type of polarization. So if it is not circular, it's not linear, it has to be. That's it. So can you give some examples of elliptically polarized waves? Anyone? Anyone? Can anyone give me an example of an elliptically polarized wave? Very simple. We take this one and we just remove the condition that E not is same. We just take this. Such that, and this is elliptically polarized. And if you can verify, if you want, you can verify that it does form a ellipse. Actually, the okay, who is the person? Sears. So the homework of Sears is to find this person. Special homework for the two Sears. Okay, more seriously. If E1 not equal to E2, then it is obviously elliptically polarized, and if verify that it does something. Any questions?
This is looking similar to the second example of linearly polarized in linear polarization.
Ah,
And
interesting.
when you are talking about the general case,
Really? Can you go back and see what I have written for the second example? It's one small
is
difference.
okay, sir, I found.
Yes. So it is not.
Yes, I found. It is shifted by
Yes.
90 minus 90 degrees.
Yes. For linear, both will be cos. So that they are in phase. Since one is cos, one is sine, it is either elliptical or circular. If the magnitudes are same, it is circular. If it is not same, it's any other question. Okay, any problems which you have stuck? Like any problems which you do not understand? Any difficulties? By the way, the last date of submitting the first assignment is on 30th. I think 9 or 10 days something. It is 30th of September. So 9 days. So please submit your assignments by 30th of September. Okay. Otherwise, marks will be deducted for